All right, week 4, here we are. This week, you are finally going to learn why it is possible that paper beats rock when we play paper, rock, scissors. So, the idea that paper beats rock is the understanding of weathering and erosion. Now, before we go any further, it is so super important that you know, if nothing else gets through your big brain right now, I need you to understand that weathering and erosion are not the same thing. A lot of times we use those two words interchangeably because eventually erosion happens, but it is not the same thing as weathering. So when we look at weathering, what we're talking about over here is we need to think of weathering as like the jackhammer or the hammer. So the weathering is the actual breaking down of rock because until another force acts upon it, that breaking down of the rock, the sediment just stays there. So weathering is the actual breaking down of rock. So just like this guy right here, when he's done breaking all that rock, if nobody goes and picks it up, it's just going to stay there, right? So weathering is the actual breaking down of rock. Now, once this guy finishes and they come and remove all these rocks and they're going to go put them in the dump truck and the dump truck's going to take it away, the actual movement of that sediment is erosion. So weathering is the breaking it down. Erosion is the moving it away, so the putting it up in the dump trunk and driving it off, or the sweeping it into the dustpan and taking it to the trash. Any way you wanted to figure it out, though. Weathering is the actual breaking of the rock, and then erosion is the actual movement of that sediment, moving it out of the way, moving it to another location. Okay, so that is the number one rule you need to remember because weathering and erosion are not the same thing, and people use them interchangeably. Don't do it. I hope I don't as I continue this lesson. So, the idea of weathering, I know in sixth grade that you talk about weathering. You talk about how we have a big rock, and then that big rock may form a couple smaller rocks. Over time, they break down and they form even more smaller rocks, and then eventually you end up with sand. Okay, now it's always interesting to me when I see these pictures because I look and I say, oh, okay, well, there's the big rock, and then the big rock broke down. Yeah, I see that. And then, oh, we got some smaller rocks down here. But what you don't ever see is the sand. Well, that's because by the time the sand breaks down into sand, it's a lot easier to be carried away. And so by that point, it's no longer sitting there because it's eroded or erosion is taking it somewhere else. But weathering is the actual breaking down sediment into smaller and smaller and smaller and smaller and tiny pieces. Okay? So weathering, breaking down from rocks into smaller pieces. Now, there are three types of weathering that you're going to need to know. You need to know about physical or mechanical weathering. You're going to learn about chemical weathering, and you're going to learn about biological weathering. So the first one we're going to talk about is the physical or mechanical. Same thing. It's interchangeable, the same idea. So mechanically wearing it down. So over time, wind blows up against the rock, and it's going to slowly and slowly and slowly weather that rock down. So that's how we get these gorgeous landscapes and these beautiful rocks that wind has slowly, slowly eroded away. Now notice though, these rocks still have a kind of a rough edge to them. That's usually how you know the difference between a wind weathering versus water weathering, excuse me. So wind weathering usually doesn't leave that smooth surface behind, whereas water can often leave a smoother finish left on the rocks once it's weathered it down. So if you see here and this picture right here, it's still jagged, but they're slowly moving and weathering away to less and less. Whereas up here in our river pictures, these rocks look a lot smoother because that water kind of infiltrates every little crevice and kind of smooths it out. So when we talk about physical weathering, we're talking about wind and water. Now, one more thing to add is this giant behemoth of a rock right here, the one that looks like Thor karate chopped it in half. So what actually happened with this rock is what we call ice wedging. It is a type of physical and mechanical weathering because it is dealing in water. Now, as you know, ice expands. So when water freezes, it actually causes these two rocks to push away. So this rock goes this way and this rock goes this way. And over time, the crevice is going to get bigger and bigger and bigger until it finally splits in two. I think this rock is crazy how it's just stayed there over time. And so kind of makes you wonder if other forces have acted upon it. But that is actually how we have big pieces fall off cliffs, because slowly over time, that water gets in those crevices, especially in the tip tops of those mountains where it's still freezing, frosty cold. Water will freeze and it expands. When water freezes, it expands. And then as it melts away, it's pushed that rock a little bit more every time. So we have wind and water through physical or mechanical weathering that also includes ice wedging. Okay, the second type of weathering we have is chemical weathering. Now, chemical weathering can be anything from a pioneer species, like we talked about last week, or it can be acid rain, or it can actually be regular rain. And I don't want you to think, well, rain is water, so that should be the same thing. The actual idea, rain is actually on the pH value of 5 or 5.5, which is slightly acidic. And when that rain falls and it absorbs into the ground, it can actually create caves, because some of our rock, depending on what rock it is, like limestone can actually dissolve over time from rain because it has that slightly acidic value to it. Now, obviously, it's not going to hurt you. You play in the rain, it's totally fine, and it's not as severe as acid rain, but it does actually have a pH balance that's a little bit more acidic than a base. Okay, so what we're looking at here is we're actually looking at how caves are created through chemical weathering, how sinkholes are created through chemical weathering. That same idea, that it absorbs into the ground and it actually dissolves the rock underneath it, and that's what causes the ground to give way after a while. And you also see chemical weathering on statues. So the statue, if you see this residue, well, it looks like residue, but it's actually not. It's actually how the rock itself is starting to melt away. And so while it kind of looks like it's almost painted on there, it's actually slowly dissolving that rock away. That's why I always, when you look at statues, you have to understand if they've been outside, there's going to be some kind of level of degradation going on where it's slowly dissolving over time and it takes out those features the artist once put there. And so chemical weathering, when you look at those statues outside, this one, it looks like her poor face has melted. This is all caused from chemical weathering, just that reaction from the water onto that rock. Now, there is some rock that takes years you will never be around, and your grandchildren and great grandchildren and even the great great grandchildren won't be around to see that one, to actually see the reaction. But there is other rock. I actually assign you an EduSmart that actually goes into that, and it shows you how some rocks will dissolve more quickly. Okay, so this is chemical weathering. So we started with physical or mechanical weathering. This is chemical weathering. And then the next one is considered to be biological weathering. So biological weathering is that idea that living organisms are going to cause those rocks to weather or break down. So if you notice in the very first picture, you see a tree. A tree is living, it is a living organism, and it has actually caused this giant rock to create a rift. It has actually broken this rock all the way through. If you see that, that tree has grown up and its roots and its trunk has actually started to expand, and it's going to continue to break that rock down. This is that whole joke of paper beats rock, because a tree obviously comes from paper. No, let's try that again. Paper obviously comes from trees, and so that tree is actually able to break apart that rock. We talked about how animals and plants make adaptations, and this is an extreme example of that right here. This tree being able to break through that rock, that adversity. This is what you should learn from. You should always be able to face adversity and come out stronger for it, and this tree is going to do the same thing. So if you look here in this rock too, you see this big giant rift in it. This is actually where it's breaking through from the roots up above it, as the roots try and grow down to find water, to find the things that it needs to grow stronger. It will cause that rock to break. It is actually super strong, and it's an adaptation for it. You can see this tree actually looks like it's growing out of the rock itself. Um, Along with trees, which we obviously know those roots break the rock apart, we ourselves, human beings, are living organisms, obviously. And as you know, pocketbooks often rule that, and we constantly tear up the earth and move it to suit our needs. Not obviously helpful to the environment, which we ruin habitats all the time by breaking it up, but we are considered biological weathering for the fact that we just rip it up. Also, insects and animals, when they burrow into the ground, that's actually considered a type of biological weathering because they dig that rock, the sediment, out for their hole, and so then that sediment sits there until another act forces upon itself, and it actually will move that sediment along later. But when that animal or that insect digs and burrows into the ground, that's considered biological weathering. And then next, you see this. This is actually a rock. It is not a tree. I know sometimes you might look at it and think it looks like a tree trunk, but it's actually rock. And that rock actually has this organism growing on it. You learned about this organism last week through ecological succession. You know that the pioneer species is lichen, which is like this orange and yellow colored covering on it. That is lichen. Lichen produces an acid that actually speeds up the degradation or the breakdown of the rock into soil. And so it's almost like weathering times two, like putting it on fast forward for 2 times faster. So it doesn't break it down obviously fast. It's not going to break down in front of you, but it will slowly over time break that rock down into soil. The same thing, you'll see this gray piece right here that's actually moss on it. And so those are considered biological weathering because they're living. Now, I want you to also realize that biological weathering kind of work hand in hand with the other two types of weathering. So over here, yes, this tree right here, this tree actually broke that rock apart. So the tree itself is a biological weathering and it caused a physical weathering because it caused that rock to break apart. The same idea over here, the lichen is going to cause that rock to chemically change into another type. And so that chemical change actually works together. So biological and chemical weathering will work together, and then biological and physical weathering work together. So they often work hand in hand. All right. Sediment is a vocabulary word you need to know. Sediment just simply means the rock. So once that big rock is broken down into smaller rocks and broken down into smaller rocks and smaller rocks, that's called sediment. So it's kind of like the middle phase between a big rock and sand. So anything in between we call sediment. Erosion. So erosion, we've gotten to that point where we're talking about the flow or the movement of the sediment. So when you look at pictures like this, the actual movement, so it's hard to see in just a picture, but when you look at it, this is actually a rock that's being weathered, okay? This is the actual erosion. So that movement, I know you're looking at it going, Ms. Hopkins, that's water. I know it's water, but that water is carrying sediment with it. And so the act of carrying the sediment with it is erosion. So this is actually the erosion. So don't be confused if it says, hey, what part of this is erosion? It's not this. It's not this right here. It is actually the water moving. That is the act of erosion. Okay, so the wind right here, this is actually the wind. You can actually see the wind because it's carrying with it the sand. And so that's the actual act of erosion. It's amazing to see how water will carve this. And next week, we're going to learn about landforms and how the act of erosion creates landforms. But erosion itself is the actual physical movement of the sediment from one place to another. Now, erosion, we talk about how erosion has an agent. It has four actual agents, and that is not agents that's signing it for big money. It is agents meaning the cause of. So erosion has four agents. They are wind. So the agent of erosion, wind. So wind blows the sand or the sediment around. So that is one cause. Another one is water. Now, obviously, I could have given you a picture right here of a beautiful, peaceful stream, but I want you to kind of realize that water isn't always peaceful and slow. It moves rapid, and when it moves quickly and rapidly, it picks everything up and it turns it into a big giant mess, and it creates a whole other realm. And we're going to go into catastrophic events, and so I kind of wanted to kind of put that picture there, kind of get your mind moving that way. Yes, water flows, and sometimes it flows beautifully and peacefully, and other times it is torrential. If you ever see a picture of the Gulf of Mexico, you'll see that the Galveston beach always looks kind of muddy and dirty, and that's because it's right there at the exit for the Mississippi River. And because that Mississippi River, that mighty Mississippi, comes rolling out and dumps into the Gulf of Mexico, it upturns all that sediment. It has it constantly roiling about and moving, and that movement is what's happening with that erosion. That erosion is pushing all that sediment out from the mighty Mississippi into the Gulf of Mexico. And so it's kind of muddy and dirty looking, just like this water is, okay? And then we have gravity. Gravity is always that force that acts upon everything else, pushing those rocks down. And then finally, we have ice. Ice glaciers actually move. They actually cause deep gouges in the rock. As it falls down, it will break up into that sediment and take that sediment with it as well. That is all of my lesson. I did give you some edge smarts to review. Make sure you go through and try those out and make sure you do the activity.